Hi everyone, welcome to this second episode in our series Field Gemology with GIA. We have today Wim Vertries, the manager of Field of Gemology for the GIA in Bangkok. I'm going to invite him to join us on this account for a conversation today about understanding mining, gemstone mining. And I would like to tell you this Instagram Live is brought to you by Gemological Institute of America, which has been protecting consumers and supporting the global gem and jewelry trade since 1931 through research, education, and laboratory services. We had the first episode of our series months ago, so you can find it on this account in the Reels. You can also find it in the feed, and you can find it on our YouTube channel, Rapaport Jewelry Pro. So if you missed the first episode in which Wim gave us an introduction to field gemology, discussing why it's important, the GIA collection of 27,000 stones, and many other things about field gemology, you can watch it. Hi Wim, how are you?
Hi Sonia, how are you today?
I'm great. I'm excited about today because we're going to talk, as I was telling our audience, the first episode was a general introduction. You went into some of the topics we're going to cover in the 4 episodes following the first one. But today we're going to do understanding mining. So I know you had already a few questions from your community. So, but before we start, I'd just like to know if people want to tell us where they're from which country, so we have a bit of an idea for who's with us today. Before we go into where are people from, can you just reintroduce yourself very briefly, Wim? I said that you're
Yeah,
obviously
for sure.
the manager for the Gemological Institute of America in Bangkok for field gemology, but just tell us a little bit more about yourself. And I should introduce
Yes,
myself as well. I'm the editor-in-chief of Rapaport. That's why I'm here. Let's
perfect.
start.
Yeah, so my name's Wim. I'm the manager of field gemology for GIA, like you said, based in the Bangkok laboratory, where where most of the field gemology collection is based. So field gemology, I think we talked about this in the previous episode. If you haven't seen that, definitely go check that out. But we tried to define a little bit more what field gemology was and like why it's important for everyone in the gem industry, not only for the laboratory. For the laboratory, it's obviously very important to have that collection of gemstones that is reliably collected, but also we touched a little bit about like why it's important for students, for cutters, for journalists, for jewelers, even for people purchasing jewelry, why it's so important to do a little bit more field gemology. And to further explain that, we broke field gemology in 4 chapters where we have the mining, which we're going to talk about a lot today. We have the gemstones, so the gemology, more technical, a little bit more technical, the treatments that are happening there. But that is obviously very important for the laboratory, maybe a little bit less for people who are in jewelry, for people who are in retail or something. But we're also going to talk, I think next time, we're going to talk about another pillar, which is going to be the trading, because it's important for everyone to know how trading happens. How does a stone get from a mine in Myanmar to a ring in Shanghai? So to understand that journey a little bit, all the steps, all the people that are connected with the stone, that is also part of field gemology for me, to understand how that stone moved throughout its entire journey. And then the fourth pillar, which I think is going to be the last session that we're going to do in a couple of months, that is going to be more about the people, about the sources themselves. Because it is very important to talk about the sources themselves. If you don't understand what a source means, for example, if you are working with emeralds from Zambia and you are selling emeralds from Zambia with that Zambia really as a plus point, but you don't know anything about the country of Zambia, that is a very big loss. For example, if you start selling rubies because they are Burmese, but you don't know what rubies mean in Burmese culture, you're missing a very big part. But today we're really going to focus on the mining. So the mining of gemstones and what that means to understand that, because there's a lot of aspects there. First of all, we have the geology, We have the geography, which is very important on like how are people mining, but also where do we actually find gemstones? Because I grew up in Belgium and there's not a single gemstone there. But I've been to countries now where if you kick a rock, you basically have a 40% chance that it's a gemstone. In places like Tanzania, there's gemstones everywhere. The Mogok area in Myanmar, there's so many gemstones there everywhere. Why is that the case, and why is that not happening somewhere else? But also, if we go a little bit further into mining, if you understand the mining and how that happens, you will understand the environmental impact that that has. So I think those are some things that we will talk about today, focusing specifically on that mining. I think we received a few questions. We put some feelers out about things that people wanted to know, things that people wanted to understand a little bit more about mining and where they had specific questions for. And I think, yeah, during the chat, you can always ask us some more questions. If there are specific stones you want to know about, if there are specific regions you want to know about, or if there are just general questions about gemstone mining. And I do want to say that we're going to talk mostly about stones like the one behind me here. We're going to focus very much on colored gemstone mining, because diamond mining is really its own world that is following, like the diamond industry is following very different rules from the colored stone industry, follows it its own way. So those are really following different rules, and the same applies to mining. The scales at which this is happening is very, very different. So that is a very interesting thing that we can observe to begin with. But today we're going to focus really on the colored gemstones: ruby, sapphires, emerald, garnets, beryls, morganites, tanzanites, spinels, things like that.
Great. Thanks, Wim. So just as you reminded, today the conversation is really about mining. If you have any other questions, please ask for another episode that Wim just outlined, sourcing, trading. Please send it to the GIA account. I see that we have people from East Africa, from Myanmar, from India, from America. We have really the whole globe covered today. That's great. And you mentioned something. You're born in Belgium, no stones. You live in Bangkok, a lot of stones. So tell us, not all places are born equal with...
Absolutely. And I think if we can look at gemstones, really at the geology, I think we can broadly separate gemstones into two different families. I think the first group that I want to discuss are the pegmatite-related family. So pegmatite is a very peculiar rock, and it is basically a concentration of very unusual elements. So unusual elements, that means that these are elements that are not very compatible with other elements. They are a lot bigger or they are a lot smaller. So you can basically compare this if you have a fruit basket and you have 100 oranges and you have one watermelon. If you want to stack all of these together, the watermelon doesn't really fit in there. So you leave the watermelon for last. That's basically what's happening in a pegmatite. You basically have all these fruits and you want to stack them all together. And obviously the oranges and the apples, they're kind of the same size, so they all go fit together. But in the end, all you're left with is the watermelons and the blueberries, the really big ones and the really tiny ones. So those make for very interesting flavors, because we don't only like oranges and apples. We like watermelon and blueberries as well. So in the end, you're left with this mix of like exotic fruits, exotic elements that often result in very interesting minerals. Examples are spodumene, kunzite, lots of beryls, because the beryllium atom is actually a very tiny and it doesn't really fit into most crystal structures. We have tourmalines that are very common there. So a lot of these crystals concentrate, and a lot of these elements concentrate in pegmatite and usually form really, really big crystals. That's why these gemstones can often be very big. I mean, some people have seen, like, there are these tourmaline slices that are the size of your head. You could never imagine that, for example, for a garnet or for a corundum, because they form in very different environments. So that first environment is really going to be that pegmatitic environment, where there's a lot of gemstones being produced, a lot of tourmalines, a lot of beryls, a lot of kunzite, things like that. Then the second environment that we focus very heavily on are really the core, the roots of old mountain chains. So these are areas that used to be extremely deep. So example, if you go from the top of the Mount Everest and you go like 10 kilometers down to what is happening in the roots of the Himalayas, there's a lot of gemstone formation happening there. But right now, that is happening 10 kilometers deep. So to see what's going on there, we basically have to wait until all the Himalayas, the Mount Everest, the K2, that entire mountain range, until it is washed away, broken down, and all that is left are the roots. So for the Himalayas, we'll probably have to wait like 100 million years, and I don't have time for that. There are, unfortunately, a lot of other places in the world where there used to be these incredible mountain chains, but they are long gone. So the only thing that's left is really those old roots that are now at the surface and exposed. For example, East Africa, like southern Tanzania and Mozambique, there's not really super high mountains there. But what we see in the subsurface, those were the roots and the cores that really like that very intense used to be buried under 10 kilometers of rock. So used to be subjected to incredible pressures, incredible heat, incredible dynamic forces that basically mold your rock like it is like a soft clay that kids play, like a dough almost. And it is there that you form a lot of gemstones as well. So that's where you form a lot of garnets and corundums and chrysoberyls. So those old roots of those old mountain chains, and those tend to be concentrated. We have a very big belt running in East Africa. So basically from, let's say, northern Ethiopia all the way to central Mozambique. But also Madagascar used to be part of it. Madagascar has now separated by an ocean, but when that mountain chain existed, Madagascar was right in the middle of it. And even further, an island further away, the island of Sri Lanka used to be smack in the middle of it. Sri Lanka right now seems like an island off the coast of India. But actually, if you go back 500 million years, 500 million years, Sri Lanka was really deep and was being that molded and that dough really deep under the mountains, where also Madagascar was being formed, where Mozambique was being formed. So already, if you understand that geology of the Sri Lankan sapphires and you understand the geology of Madagascar sapphires, that might actually already trigger some things in your head that they actually formed right next to each other. They are separated by a complete ocean now, but when they formed in those geological ancient times, that is really like, that explains why there is so many similarities between the island of Sri Lanka and the island of Madagascar. So if you understand that geology, if you understand how these things are related to each other, that already answers a lot of questions there. That also explains why East Africa is so gem-rich. Why all these ruby deposits, all these tsavorite deposits, all these tanzanite deposits, all these sapphire deposits are just littering the coast of East Africa, and why there are, for example, a lot less gems in northwestern Africa, the areas around. I'm just going to name a few countries now. I'm not going to shame them, but a country like Senegal or even most of Europe, there are none of these mountain ranges, none of these mountain routes really exposed there. So that's why there's no gemstones in Belgium, where I'm from. But that's like, for example, if you go back to Tanzania or Kenya, where those mountain ranges are completely gone, or even eastern Brazil, where there's also used to be these huge mountains, they're also completely gone. So we see now what was happening in the core of these mountains, and that explains why it's so gem-rich. That also explains why some areas in the US or in Canada, there are almost no gems, or why there are no gems related to these mountain routes. Because sometimes in some areas you do find a lot of these pegmatites. Why are there certain gems? Why is there no ruby and sapphire in Namibia, but a lot of tourmalines? Because Namibia only has those pegmatites, and Namibia doesn't have those old mountain routes. Why does Tanzania have mostly rubies and sapphires and not so many tourmalines? Because it has those old mountain routes and less of those pegmatites. So those are very important things to understand. If you understand the geology, you can really say, okay, why is this very similar to this area? Why are the sapphires in Thailand much more like the sapphires in Australia and much less like the sapphires in Burma, although Burma is a lot closer? That is because that geology is so different. So by understanding that geology better, you'll be able to understand really how they fit into the bigger picture of the Earth.
A few people are asking if they have quality gems in the places they're from, but that brings me to another question. Because the geology is different, does that require different mining technique?
That geological formation is actually the first step. And then if we can take it one step further, gemstones, we don't always find them in the rock that they form. So that is something very important to understand. And that is what geologists call a primary deposit versus a secondary deposit. So with a primary deposit, we refer to gemstones that are coming from the rock where they actually formed. So gemstones that are forming in a rock and we can still mine them directly from that rock, that would be a primary deposit. But we know by definition, gemstones are very durable, usually more durable than the average mineral out there. So when these mountains get broken down, when all these rocks, when weather and water and biological activity all work down on these rocks, they break them down, the gemstones are usually the toughest survivors. They are the ones that are least affected by this, which means that they get concentrated. So they are surviving and they get washed into the rivers. So in that river, that is then where you find more and more of these gemstones. So that is what we call a secondary deposit, where the gemstone used to be in this rock over here, but natural forces have released that gemstone from that rock. Sometimes that rock is completely gone. And then that gemstone washes down into the river. But that means that there is a complete disconnect between the gemstone that we find and the rock where we used to form that gemstone. So that complete disconnect, that means that it's a secondary deposit. So that secondary deposit is where the gemstone is no longer in the rock where it formed. It is usually in a river gravel. So that's where we find the gemstones. And then that usually makes a very different impact in how we can mine these stones. So if we are mining from a primary deposit, we have to take a lot of things into account because we are working in a rock with gemstones in it. And these gemstones can be pretty fragile. So you basically have to remove all that rock and make sure you preserve the gemstone. So if you use very intense techniques like blasting, using dynamite, using explosives, it is a very tricky thing because you want to remove as much of the waste rock, the non-gem rock. You want to get rid of as many of that as you can, but you also want to preserve as many gemstones as you can. And we know that there are areas in the world where they were using unsuitable mining techniques and they were actually blowing up a lot of their gemstones. They were turning their 20-carat crystal into 21-carat crystals, which obviously lowers the value of that crystal a lot. So these are learning curves. You have to walk that very tight line between breaking the waste rock and not damaging the gemstone. So that's very difficult in primary gemstone mining. So usually people use, when they are very certain there is only waste rock, they remove it with very intense materials. You bring in an excavator, you blast it out. But if you feel that you're getting closer to the gemstones, people are usually switching to more gentler techniques. They use jackhammers, they use manual picks that they hammer in the wall and like crumble the rock out. And when they get very close to the gemstones, people are using very subtle tools. Some people, even some of these gemstones, you can even pull out by hand. It's like picking an apple almost, and you can pull out quartz crystals from the rock. But obviously, obviously, if you put a stick of dynamite in there, there's not going to be a lot left. So there is a lot of these things that you need to walk that line between efficiently moving through the rock and getting rid of the waste material, but also walking that thin line by preserving so much gems as you can. So that is the case for a primary deposit. For a secondary deposit, it's a lot different. So remember, a secondary deposit, that is where the gemstones are no longer in the rock. They have been broken out, they have been washed into the rivers. So secondary deposits are the best. They're super easy because they already have been concentrated. The waste material is already naturally broken down and washed away. So you have a higher concentration of gemstones. On top of that, these are just in the river sediment. So these are gravels. If you've ever been into a river and you pick it up, these are all little rocks. You can scoop them up by the hand. I have seen a friend of mine wade into a river in Tanzania and say, I think there's going to be gemstones in here. This seems like a good spot. He dug his hands out, pulled up a handful of gravel, and he picked out 2 sapphires. Like, that's how easy gemstone mining sometimes can be. Obviously, there's a lot of variation between different areas, and you really need to know which spot in the river is going to be more rich. So if you can work in a secondary deposit, that is also easier. Now, the drawback for a secondary deposit is that when those deposits mature, and with maturing, I mean if that tumbling in that river has been more intense, if that transport has been longer, that means that not every gemstone can survive that. For example, if you look at softer gemstones, and with softer gemstones, I'm talking gemstones with a hardness below maybe 7.5. So even the quartz is going to be hard to survive that. Or gemstones that have a natural tendency to have a lot of fractures in them, like emeralds, for example. They won't really survive that beating that they're going to take in that river, because in that river, they are going to be banged together with other rocks, and it's like for thousands of years, for 10,000, 100,000, sometimes millions of years, they just get beaten against each other, and an emerald crystal will rarely survive that. A quartz crystal will get completely ground away, but a spinel, most garnets, corundums, chrysoberyls, alexandrites, they are usually pretty okay with it. And I think the most extreme example that we have is diamonds, because diamonds are sometimes mined from secondary deposits as well. And I think the best example are the beach deposits in Namibia, where they are actually mining diamonds on the beaches. But the nearest source of diamonds is, I believe, more than 1,000 kilometers away. So these diamonds have been washed through that river for a long time. They have traveled a huge distance, so far that they've actually even left the river system and ended up in the ocean. And that's where they're now being mined. So that's a very good example of a secondary deposit, which is a lot easier to mine, but not every gemstone can be found in secondary deposits. And for example, if we look at some of the most famous colored stone sources in the world, like Madagascar, like Sri Lanka, I think Sri Lanka is a very good example. Sri Lanka, there is almost no one mining gemstones from the rock. People are only mining gemstones there from the gravels, from the riverbeds. And in Sri Lanka, they're actually mining them directly from the active rivers, because usually the easiest way to do it is to do it in an old riverbed. So where a river used to be, where the river is not anymore, but those gravels are still there, and it is now completely covered with soil. That's a very easy place to mine, because there's not constantly water flowing against you. So people dig down until they reach those layers, and that's something that they do very commonly in Myanmar. That's something that they very commonly do in Sri Lanka, where they have specific names for those gravels rich in gemstones. In Sri Lanka, they call that the elam, so they are searching for the elam. In Burma, in Myanmar, they call that the byon, so they're looking for the byon, and that is really that old layer of river sediment, the bottom of the river, where there is a high percentage of gemstones preserved. Now, not every gemstone. These are going to be mostly corundums, mostly garnets, so rubies, sapphires, garnets, pyropes, sometimes a little bit of tsavorite. But gemstones that tend to be a little bit softer, gemstones that tend to have more fractures in them, they will not really survive that process. That is, for example, in a secondary deposit, especially if it is a bit more mature, so if it has been developing for a little bit longer, you're almost never going to find emeralds there, for example. Now, I know that in Colombia, people are mining emeralds from the river, but they're mining them right down from the mine. So these emeralds haven't traveled really far. So if you go further down that river, you're going to find any emeralds because the emeralds wouldn't really survive that process. They would be broken up into smaller pieces, smaller pieces, smaller pieces into emerald dust. So spinel is a good example where it could survive that process, where it could actually be transported further. Rubies and sapphires are great examples where a lot of famous ruby and sapphire deposits are actually named after a river because they just find it in the river or the valley where that river is from. For example, the Umba sapphires from Tanzania are very famous for their beautiful sunset colors, ranging from yellows to oranges and things like that. They're all found in the Umba River. The Tunduru River in the Tunduru area in southern Tanzania is another great example. So there's very often named after these rivers and very often closely linked to those river systems. And that is where that differentiation between primary deposits and secondary deposits is very important to make, because it's going to have a very big impact on the mining techniques that you can do or cannot do, which has a very big impact on the material you can produce or cannot produce, but also how expensive it is. Because primary mining is much more intense, both in terms of actual work you have to put in, but also in terms of capital, plus in terms of expertise, because you need to know which rocks in the primary can I destroy, which ones do I want to preserve, and when do I need to slow down and take it easier. While in a secondary deposit, it is pretty straightforward. You grab a shovel, you grab a bucket, and you start shoveling gravel. So that is a very big difference between those two. That has a very big impact on mining techniques, but also on the gemstones that are being found there.
That is fascinating explanation and really in depth. Thank you so much. And we had a few questions as you were speaking, but I don't want to interrupt you. We'll go back to the questions. Thank you so much for. I'm so happy. Yeah, someone says really a fan of your lectures. Someone asked if all the mines are free to access. No. What is the impact on the actual environment? Because a lot of people, when they talk about mining from our industry or outside the industry, they always think of the impact on the environment. So is there a difference between the two types of deposits? Is there a difference between the country? How do you explain that to the layperson that can then relate to the end consumer?
Yeah, so the impact on the environment is a very difficult subject to discuss because it is really case specific. It depends on the actual location, it depends on the actual mining, and it even has changed throughout times. In some places, they were doing extremely destructive mining. In other places, they were not doing it. So it's very difficult to judge that. The first thing we need to realize is that all mining by nature has a destructive component because we are taking something from the environment and taking it out and not replacing it. Because we are looking for that resource, we are looking for that gemstone. So inherently, there is a non-sustainable aspect. We can only mine that gemstone once. We can take it and we can take it out. So that is something that we always have to keep in mind. Now, there are a lot of different ways that we can look at that impact, and it really depends on the location where you are, at the environment. There are so many factors that come into play that it is really difficult to just say mining is good for the environment or mining is bad for the environment. There are some things where it is good, some things where it is not so good. And there's always that spectrum, and there are always arguments, and some of these arguments can be very objective. That everyone says, yes, we could do this better. But some things for a lot of these things, you have to make the calculation for yourself. Do I think this is more important? Do I think this is more important? And that is not something that anyone can tell you. And there are ways that people try to quantify this, but because it is such a complex matter, it is very difficult to really come to a unique answer. And even understanding the impact on something is very difficult. Understanding the impact of gemstones, because it plays at so many different levels. Obviously, we can limit ourselves to the environmental impact for this kind of aspect. But we also have to look at the human impacts, because there is an economic need for these gemstones in most places where they are being mined. So how do we balance these against each other? Now, obviously, one thing that we can bring up that gemstone mining has the advantage compared to a lot of other minings, especially when it comes to metal mining, is that gemstone mining is chemically pretty pure. There is absolutely no need to use any chemicals during any type of gemstone mining. While, for example, when certain metals are being mined that could release acids into environment, sometimes dangerous chemicals are being used to leach out gold from mines and things like that. That is never the case for gemstones. So even if it is destructive, it is only going to be mechanically destructive. So it is not going to chemically contaminate the soil or the water that is nearby. For example, when gold mining, a lot of artisanal gold mining, people use mercury, which has an incredible impact on the environment and not in a good way. But that is never going to be used in gemstone mining. Gemstone mining, it is really more on, it is taking these materials out, maybe breaking some rock, but we're not really going to introduce new chemicals in the system. Now, some things that can happen is environmental destruction. And there are, sometimes when you go to a mining area, you can look at it and you can see, oh my God, this looks terrible. Everything is stripped here. But you also have to keep in mind that we need to look at this a little bit longer than a short window of our visit, or even we need to look at a window that is longer than 5 years. Because we look at this from a very human perspective, but if we look at the environment, in my opinion, we should look on a longer time scale. How fast will the system recover? And that sometimes takes 20 years. Sometimes it needs help to recover. And if we do, we can help it. If if people can help recover that system, where we have taken some resources out, if we can help it recover quicker, or if we convert it into something that is more useful, that is a lot of benefit to it as well. But just taking the stones and abandoning the mine site, I think that's a terrible practice. Because yes, nature will reclaim it, but not always in a good way. I think either reconverting that land, I know in certain mines, people are using that land to turn it into fields. Some people replant native crops, native plants to restore the forest there. But obviously this is often done on a span of 5 to 10 years. So it's very easy to go to a large mine and say, look at all this destruction they're doing. There might be like 1 square kilometer of just like barren ground when you visit. But I think, in my opinion, it is important to go back 5 years later, 10 years later, and see what the impact of it is. And I think this applies both to large-scale mining and small-scale mining, because both of them, they can have the same pitfalls, the same questions, the same problems come up. They obviously have different means to address this, but that doesn't mean that the problems are any different. I think one very good, very interesting case study that I've seen, where a miner was actually able to turn his mining operation into a very profitable second operation, was in Western Thailand, where in the area around Kanchanaburi, very productive sapphire fields were found there, and it was probably the most important sapphire producing area in the 1980s. But by the late 1980s, production was getting lower, but these people had dug holes that were 100 meters long, 30 meters deep, these huge craters there. But also the area of Kanchanaburi is one of the hottest areas in Thailand. And believe me, it gets very hot here, and Kanchanaburi gets even hotter, which means that water can sometimes be an issue there. So those huge holes, they naturally filled with water, and the owner of that mine, he was smart enough to use that water. He stocked fish on it. So you can go fishing there, sports fishing there now. So he's making an income with that. He's using that water to keep a plot of land around his old mine, keep it very green, and install a golf course there. So right now he is the proud owner of the Blue Sapphire Golf Resort in Kanchanaburi. So he has used his sapphire pit where he destroyed the environment and really converted it into an economic catalyst for the region. So that is one example. I think in some other regions, the land is simply too precious to leave it untouched. If we go to the other side of Thailand, where there is a lot of sapphire mining as well around the city of Chanthaburi, so a different part of the country, the soil is very fertile there. So people mine the sapphires, but they immediately want to plant crops on it. They immediately want to start doing agriculture again. So I've been visiting that area very regularly over the last 7 to 8 years. And there's places now where I have stood in a hole that was 40 meters deep, where there are now bananas and mangoes growing. So in that span of 7 years, you really see that changing. But if you only do a single visit, you would see, oh my God, they dug this huge hole here. This is not really good for the environment. This is very dangerous. But you see that they convert it very quickly. Now, obviously, in a lot of areas in the world, there is not that much understanding. There is maybe more pressing economic needs where sometimes these mine sites can be abandoned and left to nature, where nature will reclaim these over time. But that might not mean that it's returning to the exact same state that it was before. So environmental impact of gemstone mining is very hard to estimate because it really depends on the place, the time, the gemstone, the style of mining where you're at. But if you look at specific areas, you're going to see different stories there and different elements that maybe you personally give more value to. So that's why understanding that mining and how that happens in the areas where you are working with the stones can be very important for you.
Thank you for sharing this example. A lot of questions, but I have one. Someone said the book recommendation to learn more about it. I'll be tempted to go and learn with a GIA.
I think during GIA classes, we touch on a lot of this material. And I think also if you already have a basic GIA education, there is more advanced education becoming available. I think most of the literature or most of the resources available on this topic are actually very in-depth and very specific. There are books out there that are dedicated to the geology of gemstones. There are research groups at universities working on estimating the impact of gemstone mining in certain regions, both in the economy and on the environment. But usually that is very much into the academic scene. So unless you have a degree in geology, these articles could be quite difficult to understand. So that is why we are making some effort in something like this, where we are trying to bring some of that information to the general gem and jewelry working public, which we know don't all have advanced degrees in geology or geography. So this is really the start of a conversation that we're having about this, that I hope has piqued some of your interest, that you can dig a little further in it, because there is some trade literature out there as well in magazines. I know that Rappaport has talked about some of these aspects. The Journal of Gemology, Gems and Gemology, other magazines have also talked about it. I believe at trade shows, we are starting to see more and more attention on sustainability. Usually that is going more into focusing right now more on human development, but obviously that natural preservation is also a really big part of that. And that is a discussion that is going to come in more and more, and that discussion is not going to go away. In fact, these questions are only going to keep coming more and more and more, which is what we see in the chat here. Like, the amount of questions we get is unbelievable. That's really helpful for our next sessions as well. That's really going to help us a lot. But that is going to be very important to further understand this, to further look into this, so that we can all have this conversation again. Because I think this is the first time that GIA has really opened this conversation online to a broader public. And it's amazing that you're all here. Like, there's hundreds of people in this chat. So I think also for Rappaport, I think this is the first time that we're really focusing on colored stones and like really talking about this mining and like having a conversation about this. So I hope that this is really something that is going to continue in the future as well, in whatever shape or form this is going to happen. But don't let that hold you back to look into these things by yourself, because there are things out there. You might have to dig a little bit for it. They might be too complex. They might not be exactly what you're looking for, but there are things out there. I think for people that are interested in like really more the technical geology, there is a book called Geology of Gemstones, which I believe is published by the Canadian Mineralogical Association. That is a wonderful resource, but it gets quite technical most times.
Also, I would really encourage people to check the website of the GIA. It's like a great resource.
Not only the website, by the way, but also the YouTube channel, where I think during the wonderful, like the horrible period that we all lived through 4 years ago when we all had to stay at home, we used a lot of our time at GIA to create a lot of these seminars on specific topics. And there are seminars that focus really on discussing diamond mining, on colored stone geology. So a lot of these aspects are touched upon there as well. So you can find that on GIA's YouTube channel, GIA social media. There's a lot of links there. And obviously GIA.edu, the website, where you can also find a lot of that information.
Someone said it would be really nice to have another episode, and you're in luck because we have more. We have more comments episode. But if you have questions, please, as I said, send us a message to the Rappaport Jewelry Pro account, or to the GIA account, or to Wim's directly account. We're going to share it in the recording of this reel, so you'll be able to reach all of us.
Thank you so much. See you guys next time, where we'll talk about the trading and the sources and the actual gemstones themselves as well.
Absolutely. So stay tuned. If you've missed the beginning of this interview, it's going to be on our in our reel section in the feed of Rappaport Jewelry Pro, and it will be very soon on our YouTube channel as well. And as I said, thank you so much for joining us. I see there were a lot of questions about things that are not directly mining, but we'll address them in a future episodes, especially about lab-grown stones and sourcing. So we'll have all the with Wim very soon. Thank you so much for joining us.
Thank you, guys. Have a great day. Bye-bye.
Bye-bye, everyone. Bye.